Hello, one and all. My name is Hemant Reddy Musipatla from Tech Warriors Network Intrusion Detection System. So for this project, we used dataset KDD Cup 99. KDD Cup 1999 is a benchmark dataset for a network intrusion detection system. It contains network traffic data that represents different types of attacks on a simulated computer network. Dataset purpose. The purpose of the dataset is to build a predictive model capable of distinguish between bad connections called intrusions or attacks. Hence, KDD Cup 99 dataset was created as a part of annual data mining competition in the year 1999. So we call it as KDD Cup 1999. So what are dataset characteristics? The dataset characteristics are uh, which consists of network traffic data in which connections between IP addresses are labeled as normal or attack with specific attack types. So what are the specific attack types? So the attacks are categorized into four types, which are DOS, R2L, U2R, and probing. So what is DOS? DOS means denial of service attacks. R2L means unauthorized access from a remote machine to local. U2R means unauthorized access to local super user, which is root privileges. R vision. R vision is to predict if an attack is normal or an anomaly using a set of machine learning algorithms trained on a labeled data set of normal and anomalous traffic. So particularly we want to work on DDoS. So for DDoS attacks, the features that constitutes of DDoS attacks are backland, Neptune, POD, Smurf, teardrop. These are all the types of DOS attacks. So for this, we have to inspect the data first. For inspecting the data, we need to import the data first. We import the data using pandas. So from using pandas dot read CSV file, we read the data set. So after that, we have used data.head, which inspects first 5 tuples of the data. Uh, and after that, data.shape represents give returns columns and rows. The columns is 42 and the rows is 494020. So after we transport the data, after that we inspected data.d types, which are into three types: integer, object, and float. So for data preprocessing, identifying missing values in KDD Cup 99 data set, we used is in a we got known null values overall. Exploring all attacks in the label, we got 23 total types of attacks, which constitute Smurf, Neptune, normal, etc. After that, we have exported all the attribute names as a tuple to a new CSV file with a name pre-processed. Then we extracted only DOIS attacks, which is our problem statement. So now the data set, new data label consists of 7 attacks, which is Smurf, Neptune, normal, bacteria drop, POD, and LAN. So upon visualizing this distribution of protocols, here UDP contributes 4.1%, TCP 38.1, and ICMP 57.8. These are the distribution of protocol types. And after that, classification of device attacks, Smurf has a larger portion, which is 757.5 of Smurf attacks, normal 19.9, and the land 0.0. Now my friend Sai Krishna will continue.
Hello everyone. Let us talk about mapping categorical data. Here we created dictionaries to map categorical data in the protocol type, service, and flag columns to numerical values. Then we used map function to apply these mappings to the representative columns in the dataset called new data and transport the data. Here in our code, 0 is considered as a normal attack and 1 is considered as divorce attack. Here we can see 3,91,000 are divorce attacks and 97,000 are normal attack. Next slide. Let us talk about feature engineering. What is meant by feature engineering? It is extraction and transformation of variables from raw data. We used recursive feature elimination RFE with logistic regression model. We get a few doubts. Why RFE and why logistic regression and why combination of RFE with logistic regression? RFE is a method for feature selection that removes the least important features from the input dataset to build a model. Logistic regression, we already know about logistic regression. It is used for binary classification that estimates the probability of a binary outcomes based on input features. By RFE with logistic regression, is a powerful technique for identifying most important features by recursively removing less important ones until the desired number is reached. Let us talk about feature importance. Here we used extra trees classifier, that is decision tree. The feature importance scores provided by the extra tree classifier can be used to identify the most important features in the input data. The higher the feature importance score, the more important the feature is for the predicting the target variable. In our code, we fit X and Y, that is training and testing, to the decision tree classifier by clf.feature importance. We got all feature importance in the format of descending order. In the right side, we can see all the features are in the format of descending to the bottom, so that we can remove the less important features. Here we can see dropping less importance features. All the features like duration, flag, DST, bytes, land, and all these are less important features, so that we can uh, remove it. Next slide. Let us talk about correlation plot of the feature. For the correlation plot, we need to import Seaborn. Correlation features are used to identify the degree of association between two variables. The correlation coefficient ranges from -1 to 1, where negative values minus is indicated by -1, and 1 is indicated for positive values, and 0 indicating no correlation. Correlation features can be used to identify potential relationship between variables, but they do not necessarily indicate causation. The features which are highly correlated represented in thick color. Here we can see the dark red color, which the correlated represents with a thick color. Next slide. Let us talk about the important slide, that is data split. What is meant by data split? Data splitting is when data is divided into two or more subsets. Here, the division is taken place into two parts. One part is used for evaluation, that is testing, and one more part is for training the model. We have taken 25% of subsample data from training set, where X variable consists of all feature except label, and Y variable contains label. We split our data in the ratio of 70 is to 30, where 70% of the data is for training and 30% of the data is for testing. We did this using sklearn package model, where uh, the package is sklearn dot model selection. Next, my friend gonna continue the.
Model building. Model building is a crucial part of machine learning, and it involves creating a mathematical representation of system or process that can be used to make predictions or classifications. Here are some of the general steps followed while doing model building. First, we define the problem statement, then we collect the data, clean and pre-process the data, we choose a model and we train a model, then we validate a model and we optimize the model and deploy the model based on the data. The process of model building in machine learning involves creating a mathematical representation of real world problems which can be used to make predictions or decisions based on the data and algorithms. There are multiple model building classifiers. For example, Gauss naive Bayes classifier is a probabilistic machine learning algorithm used for classification of tasks. That it is based on the Bayes theorem and assumes that the features are conditionally independent of each other given the class label. The model selection module in the scikit-learn library provides the functions that are commonly used for tasks such as splitting data into training and testing sets, perform cross validation, and parameter tuning. It is essential for model building to build and evaluate machine learning models. From scikit.naive, sklearn.naive base importing Gaussian NB, the scikit-learn library provides a convenient implementation of Gauss naive Bayes algorithm through the Gaussian NB class. This imports the Gaussian NB class from the naive Bayes module of the scikit-learn library, which provides the implementation of the Gauss naive Bayes algorithm. We can create the instance of class and use its method to train and test our model. After creating an instance of Gaussian NB class and initializing it with the desired smoothing parameters, the fit method can be used to train the classifier and on the training data and their corresponding labels. Once a classifier is trained, the predict method can be used to predict the labels of new data. In this case, the test data used and trained classifiers. Overall, Gaussian naive Bayes algorithm is a popular and effective algorithm. And here we can see the confusion matrix. In confusion matrix, 0.0 and 1.0 typically represents the predicted class labels for the binary classification problem. The confusion matrix is a table that summarizes the performance of the machine learning algorithm by showing the number of true positives, true negatives, false positives, and false negatives. In the binary classification, the problem there are two possible classes. One is positive and the negative. The positive is represented by 1 and the negative is represented by 0. A confusion matrix is a table that is used to evaluate the performance of the classification model by comparing and predict class labels and actual class labels of the test data. Next, the decision tree. The decision tree classifier is a popular machine learning algorithm used for classification problems. It works by recursively partitioning the data into subsets based on the values of the import features and assigning the class labels to each leaf node of the tree. The decision tree is built by choosing the best features to split data into each node. In scikit-learn, the decision tree classifier class can be used to train a decision tree module. The decision tree classifier is imported from scikit-learn, and then an instance of the classifier is created with the specific hyperparameters such as splitter, creation, and max depth, min sample split, and min sample leaf. This code imports the decision tree classifier from the scikit-learn library, and the classifier is initialized with certain parameters such as splitter type, creation, and max depth. After creating the classifier instance, the fit method is called to train the classifier on the training data, for example, X train and Y train. The predicted method is called to make predictions on the test data X test, which are then stored into Y prediction variable. It is worth noting that the choice of hyperparameters can be a big impact on performance of the decision tree classifier. For example, larger the max value depth can lead to more complex tree and may overfit the training data, while the smaller value can lead to a simpler tree that may underfit the data. Therefore, it is important to tune the hyperparameters of the tree to optimize its performance. It is worth noticing that the accuracy is just one metric to evaluate the performance of the classification model depending upon the specific problems and the distribution of classes in the data. Other metrics like precision, recall, and F1 score may also be important to consider. It is always a good practice to evaluate the models performing on multiple metrics and compare it to performance on other models to choose the best one. So now my friend is going to continue with the other models.
Thank you, Suchit. Myself, Sai Krishna. I'm here to explain the third model of our project, that is random forest classifier. The random forest classifier is a powerful machine learning algorithm that is mainly used for the classification task. So it's also known as like ensembler learning method that usually combines the decision trees. Basically, we build a multiple decision trees in the random forest algorithm, and by combining all those decision trees, we make a final prediction. So each decision tree is constructed with a random subset of the training data. So which helps in the reducing the overfitting and increase the accuracy of the model. Uh, the process for random forest classifier in Python is, first we need to import the libraries such scikit-learn library from by using the, then we need to create a new instance for the forest classifier, and then we need to store it in a variable called RFC. So after that, we can train the random forest classifier based upon the training data and the testing data by using the fit method. Then we use xtrain and ytrain as a variables for the training and testing data. And finally, we train the model by using the random forest classifier. This is how the random forest classifier algorithm works. Coming to the next slide, the random forest evaluation, we got the training accuracy of like 99.08% and the test accuracy as 99.03%. In addition to this accuracy, like precision, recall, and F1 score, we also you made the confusion matrix. The confusion matrix is basically it's like it distinguishes how many samples were correctly classified and how many samples were incorrectly classified. So in addition to that, we also built the ROC curve, that is receiver operating characteristic curve. So normally it is very rare to achieve the ROC curve with a perfect inclination. Uh, the good ROC curve values like the AUC value is greater than 0.9, but we got the AUC value of 0.99 according to our slide. So Coming to the next classifier, that is KNN classifier. KNN is a machine learning algorithm that is used for the classification task, same as a random forest, and it is also known as lazy learning algorithm, which means like it doesn't learn a model from the training data. Instead, it memorizes training instances. It mainly works by finding the closest neighbors to the given data as an input, and then it assigns the further data points to the nearest neighbors. The class label of the new data is determined by majority vote among the k nearest neighbors. To implement the KNN classifier in Python, we use the k neighbor classifier from the scikit-learn library. Then we create the instance for the k neighbor classifier, and we do same thing like training the data and testing we split the data into the training and testing, and once the model is trained, we make the predictions on the data. And finally, we got the KNN classifier evaluation with a trained accuracy of 99.05% and the test accuracy with a 98.97%. Then we got the confusion matrix, and we got the all the precision score, recall, F1 score, and the ROC score for the KNN. And coming to the comparison of accuracy, we perform like four algorithms, that is naive Bayes classifier, decision tree classifier, random forest classifier, and KNN classifier. Among all of these algorithms, we got the highest accuracy for random forest classifier with 99.02%. And these are the bar graphs, and the comparison curve shows that uh, first it has been increasing gradually from the naive Bayes classifier and the decision tree, and it reaches the highest point at the random forest classifier, and then it gradually decreases at the KNN classifier. So we conclude that the random forest classifier work well. So we use the four different classifiers. So among all of them, the random forest has performed very well. We evaluate the performance of the each classifier using the testing data and training data, and measure the accuracy for all the classifiers. Out of all models, the random forest performed with the highest accuracy. So overall, our results show that the random forest is an effective classifier for predicting the DDoS attacks, and it can achieve high accuracy in both training and testing phases. So it is very important to note the accuracy as a best evaluation metric for the uh, for the classifier. So other metrics like precision and recall, F1 score is also considered. So I conclude that the DDoS attack, according to our project, the random forest work well when compared to the other algorithms. Thank you.